Hello everyone. Now we are going to discuss about the normality test. You see here, for some of the statistics to be performed, it is the assumption that two data set or two variable must be distributed normally. So there are the various assumptions. One of the assumptions to perform many parametric tests is that they are normally distributed. Data are normally distributed. For that things, we have the different methods, like we have the graphical methods and numerical methods. So here, an assessment of the normality of the data is a prerequisite of many statistical tests. As I told you, normally those parametric tests like t-test, like ANOVA. So these are the prerequisite. Normality test is prerequisite test for that one. So we are going to see with the help of example, like how we are going to see that is there two data which we are going to perform, two variables for which we are going to do the test are normally distributed or not. Like see here how we are going to do it. Like I will tell you through the different methods, like one is skewness and kurtosis, and one is there is one more data is there. I will show you according to that one. So how to perform it? This is the path which we have to follow, like analyze, descriptive statistics, explore. So you will go to the analyze for that one, descriptive statistics, then explore over here, and then there is a two variables here you have to be observed here, like this is the nominal and this is the scale variable. If nominal variable is there, then we will put this nominal variable in the factors and this scale variable on the dependent. Also you will see that course is dependent upon the time. So here then we will click on the statistics, and you can see here the time, and we can put the whole course over here. One more thing which I would like to say is that suppose both of the variable is scale. So in that case, no need of putting on the factors list. Directly put both, 2, 3, whatever the variables you want to check whether they are normally distributed or not, all in the dependent list. Okay. So with the help of one example, we are going to see it. But how we identify whether they are normally distributed or not. So after these things, we will click on explore statistics. Descriptive 95% is there. Normally we take the 95% confidence level, no issue on that one. Again you will go to the explore plot, and here you can check on stem and leaf or histogram is better, and don't forget to click on this one, normality plot. Then click on continue. You will find one descriptive table and one this table, test of normality, Kolmogorov and Shapiro-Wilk. We are going to take the Shapiro-Wilk table. If this significance level is above 0.05, it means my data is normally distributed. Above 0.05. So in this case, it is there. And also we can see through the descriptive statistics. I will show you through the example. Where if the skewness is between -2 to +2 and kurtosis is between -7 to +7, we can say is this data is normally distributed. Let us take the example so that it will be more clear to you. So I'm going to take this t-test first. Suppose we are going to perform t-test for this data. Before performing the t-test, we should know that whether these two variables are normally distributed or not. For that things, what we have to do it, we will simply go to the analyze, then we have to click on descriptive statistics, then click on explore. It is already there. So now I told you, like if both are scale, so in that case we will put both variables on the dependent variable, and if one is scale, one is the factor or nominal data, then one we will put over here. And we take another example for that one. Now see on the statistics, yes, 95% is there. Okay, continue. Then click on plot. In the plot, leave the system and leave, click on histogram. So because with the help of histogram we will find the value of skewness and kurtosis, as well as don't forget to click on normality plot. Then click on continue, click on OK, then see the result. You can see the result in the output window. Here if you can see this plot, before that one, skewness is 0.691, which is above -2 and below +2, so it is acceptable. Kurtosis is also above -7 and below +7, so it is in the range of normal distribution. It is before training. Again, after training, the range is again same. Range is there. It is minus 0.959. It is below +2 and above -2. It is kurtosis is also above -7 and below +7. So this is one of the range. We can say that this is the normally distributed. Other thing is that we will also check this Kolmogorov-Smirnov or Spearman. We will take the Shapiro-Wilk. Shapiro-Wilk test is saying that if our significance level is above 0.05, it means we can say this is normally distributed data. Here you can say it is 0.378. Yes, it is above. Also, after training is 0.024. It is also normally distributed. So we can say that this data is normally distributed. So we can say that we can perform this t-test or whatever. Now let us take the another example where employee data, which we used to say we used to take various times for performing various statistics. So here in this case, again, what to do it, we are going to see like in this case analyze descriptive statistics, then explore. Here let me first reset it. employee category employee category and current salary is my dependent variable, and we can see that the employee category or binary classification whatever. So here we can see on the plot, leave this stem and leaf histogram, the normality plot. We can check whether they are normally distributed or not. So here again we will see in the output window. In this output window we can check here. Yes, skewness is above -2 and below +2. So and kurtosis is more than 7. So here this one is not normally distributed, I think so. Let us go and see this one. Here it is saying that it is below 0.05. It is below 0.05. It means this data is not normally distributed, so we are not going to perform that task. We have to take the alternative test for that. So this way we can say that we are going to test whether the two set of data is normally distributed or not. So this is the way we can perform that one. Thank you.